Today we're going to talk a little bit about trig functions of any angle and then a few applications. And so what we're going to move off of is we're used to our sine opposite over hypotenuse, etc. And so we're going to move when we are on a coordinate, okay, and we're going to talk about an angle in standard position. And I'm going to go ahead and draw my angle. So here's my initial side, here's my terminal side, okay, and here's my theta. Okay, so we're going to have a point xy that sits right here on the terminal side of theta, and this is going to be our radius here from 0, 0 to xy. Okay, do a little Pythagorean theorem. Now, what we're going to kind of begin to work off of is that we have this triangle here, okay, and we can find sine, cosine, and tangent, and this will take you kind of from your unit circle. This is our x, this is our y, and this is our r. So we probably will still think a little bit like opposite over hypotenuse, but we're going to kind of move to a more generic term, y over r, the vertical over the hypotenuse, the horizontal over the hypotenuse. So still sine, cosine, and tangent, and then our 6 trig functions, the last 3 are the reciprocals. Okay. So let's just kind of jump in and take a look. So let's draw this. Okay, negative 3, 4 would sit, let's say, about right there. So here's our angle, and here's our theta. Okay, and that's negative 3, 4. Okay, so negative 3, vertical is 4, and you can either do the Pythagorean theorem or know your Pythagorean triple. So this is 5. And remember, this is negative only because of the location it is. It's on the left side. The actual measurement is 3, but we say it's negative 3 because of the direction. So I set my triangle up, and then I remember sine theta is y over r, which means this is going to be 4 over 5. Cosine theta is x over r, so negative 3 over 5. And then tangent theta is y over x, which would be negative 4/3. Okay, and if that bothers you and you want to make it 4 over negative 3, that's fine. Okay. Another method that we can do is I tell you sine theta is negative 2/3 and tangent's greater than 0. Now here's how I do these kind of questions. Sine is negative, so I'm going back to my all students take calculus, all sine, tangent, cosine. I need sine to be negative. So if sine is negative, it can't be in quadrant 1 and it can't be in quadrant 2. So now I have to decide which 2 of these quadrants it's going to be. Okay, sorry, I got interrupted, so let's see where I am. I know it's going to be in quadrant 3 or quadrant 4, and then I look at this condition. Tangent theta has to be positive, so that lets me know that I need to be in this quadrant right here, because here's where tangent's positive. So then I draw my triangle here. Okay, remember this is y over r. R is always positive, so it's always going to be positive 3. This will be negative 2, and then you'll do a little Pythagorean theorem. 3 squared minus negative 2 squared is going to equal a squared. So 9 minus 4, so 5 equals a squared, so this will be the square root of 5. Okay, then once you know that, so cosine theta is x over r, so root 5 over 3, and then cotangent theta is x over y, so that would be root 5. Oh, you know what? Look right here, y'all. That should be negative because I'm on the negative x-axis. So negative root 5 over negative 2. so root 5 over 2. Okay. Evaluate the sine and cosine functions for the quadrantals. Okay, so reminding you about the quadrantals. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay. Sine of 0, cosine of 0. We can just use our x and our y, so 1 and 0. Okay. Sine of pi over 2, cosine of pi over 2. Just going to use our x and y's. Y is 1, cosine is 0. Then sine of pi, cosine of pi. Sine is 0, cosine is negative 1, and then our 3 pi over 2, where my sine is negative 1, and cosine 3 pi over 2 is 0. Okay. Okay, so sometimes you're going to be asked about a reference angle, and you use that reference angle so to help you with your triangle. So right here, it gives you the definition. Let theta be an angle in standard position. Its reference angle is the acute angle theta prime formed by the terminal side of theta and the horizontal axis. So if I tell you theta is 100 degrees, so we would draw our angle in standard position. Here's our theta. Theta is 100 degrees. Okay. Our reference angle would be 80 degrees. Theta prime would be 80 degrees. It's always between the terminal side and the x-axis. Okay. If I told you theta was 5 pi over 4, so hopefully at this point in our lives we're getting better with the radians. 5 pi over 4 sits down here. So here is my theta. Okay, it's 5 pi over 4, but my theta prime is going to sit right here, and so my reference angle would be pi over 4 as we sit there because the distance here to here. Okay. Sometimes you'll get asked about what happens if you have a negative angle. Okay, so negative 2 pi over 3. That's going to sit right here. Okay, negative 2 pi over 3. And then my reference angle will sit right here, theta prime, and theta prime will be pi over 3. Okay. If you need let's try these reference angles. So 300 degrees, that would sit right here. Okay, 300 degrees. So what's left for my theta prime is this angle right here, and that would be a 60-degree reference. 3 pi over 4 sits right here. Okay, then here's my theta prime, and that would be pi over 4, and then negative 120 degrees sits down here. And my theta prime would be 60 degrees. Your reference angles are always going to be positive. Okay. Now, evaluate each trig function. Okay. So, some of you will already have some of this memorized from our unit circle work, but cosine 4 pi over 3, that sits right here. Okay. Our reference angle is just going to be pi over 3. So that makes this negative root 3. That makes this negative 1. And our radius is 2. And cosine is x over r. So that would be negative 1/2. Negative 210. There's negative 180. There's negative 210. Which makes our reference angle 30 because that would be the measurement between the angle. So now this is 1, this is negative root 3 over 2, okay, and not negative, sorry, that's negative root 3 and the radius is 2. Tangent is y over x, so So this would be negative 1 over root 3, and then we would rationalize that and get negative root 3 over 3. Okay. Sometimes I ask you crazy things, like 11 pi over 4. So let's think about this. Here's 0, here's 4 pi over 4, here's 8 pi over 4, here's 10 pi over 4, and here's finally 11 pi over 4. Okay, that makes my reference angle here pi over 4. And okay, so my x's are negative. Now I'm using this on my 45, 45, 90 that I worked with. Cosecant, so sine theta is y over r, so that makes cosecant theta r over y, so the radius is 2. And my y is root 2. And I need to rationalize, so I'm going to get 2 root 2 over 2, which is root 2. Okay, and then the last little bit for today is just talking about just some more application problems. Some will feel like the kind you've seen when we're in geometry. Okay, an airplane flying at an altitude of 6 miles is on a flight path that passes directly over an observer, looking at the figure. If theta is the angle of the elevation from the observer to the plane, find the distance d from the observer to the plane when theta is 30. Okay, so here's what I happen to know. Let me put this so I can see it a little bit better. I know this is 6. This is my theta, so this is opposite. Looks like I'm trying to find my hypotenuse or my radius. So I can do sine 30 equals 6 over d. Now, I would hope a lot of you would know that sine 30 is 1/2. Okay, you need to get to that place if you're not there yet, because this would probably be on a non-calculator question. And then I could cross multiply and the distance would be 12. Sine of 90 is still 6 over d, but sine of 90 is 1. So d would be 6 miles. I guess we should put miles. And then 120 degrees. Okay, so let's think about 120 degrees. It sits over here, which makes 60 degrees the reference angle. So 60 root 3 negative 1 and 2. So this would be the square root of 3 over 2 equals 6 over d. Do a little cross multiplying. D root 3 equals 12. D equals 12 over root 3, and then rationalize the denominator, which would give us 4 root 3 miles. Okay, and then I'm going to get you started on this one. It says a steel plate has the form of 1/4 of a circle with a radius of 60 centimeters. So the radiuses are 60. Okay, two 2-centimeter holes are to be drilled in the plate, shown here. Find the coordinates of the center of each hole. So we're going to find these coordinates. Okay, now right here. Okay, so I guess which one we can. I guess we can do whichever one we want to first. So let's do x1, y1. Okay, I'm going to draw myself a little triangle. Okay, x1, y1. Okay, we know this radius is 56. Okay, we know that the angle is 30. Okay, so if I want to figure out the y value, okay, then I could do opposite over hypotenuse. So sine of 30 equals y over 56. Okay, the sine of 30 is 1/2. 2y equals 56, so y is 28. Okay, so y1, we're doing x1, y1 on this one. Okay, so y1, what am I doing there? We just figured out that the y value is 28. Okay, and think about a 30, 60, 90. If this is 28, okay, then this is my long side, so this is going to be 28 root 3. Okay, then we can do that same process right here, okay, for x2, y2. Okay, so now that angle is 60 degrees. I kind of always work in sine. I don't know why I always work in sine. But now I can say the sine of 60, okay, so it's going to be y. Now please notice this is still 56. It's going to be y over 56. Sine of 60 is root 3 over 2. Okay, so if I multiply that 56 over, 56 root 3 over 2 equals y, so I get 28 root 3. Okay, so now that I'm doing my x2, y2. So this is 28 root 3. Okay, so think about this. If my 60, my long side is 28 root 3, then I know my short side is 28. Okay, I hope that is helpful to you. Go ahead and work on your practice on 15 and 16. We'll see you soon.